Hi, this is Jacob Roden for Engineering 185. For my student project this quarter, I made a 123 block, machinist 123 block. On the right here, we can see the finished part. Let me move along here. What is 123 block? Machinists, like we have here at Amtech, use 123 blocks. We can use them to inspect parts. You can also use them to set up machines and set Z heights. They're 1 inch by 2 inch by 3 inch, hence the name 123 block. And there's also like 246 blocks and I think a couple other common-ish sizes, but 123 block's the most common, just because it's nice for using something as a reference when you're setting machines up and setting Z heights, or doing tool offsets, or if you ever need a fixture apart, sometimes you can use these to fixture parts, especially if it's like an irregularly shaped part. You can use 123 blocks and some toe clamps to quickly kind of just throw something in the machine instead of having to sit there and machine out a fixture plate or a more complicated fixture just for a first prototype part, or if you just have a one-off part that you're trying to make, it makes it nice and easy to actually throw it in the machine. And obviously the purpose of this project was to design and recreate a 123 block and then create a print for it so that it could be manufactured just like you would if you're trying to make a real one or any other part or anything. And here we can see some other views of the 123 block. So for the sketch, it was just a napkin sketch, pretty much, kind of mostly off the top of my head. I work with these pretty often at work, so it's not. It's something I'm very familiar with. So obviously, the hand sketch we can see. The only things I really had to actually search for were the thread that they most commonly have on them. There's a couple of variations depending on which ones you get, but that was the one that I found for this kind of 123 block size, and then the actual hole size itself. And obviously here on the left we can see an example picture that's very similar to the one that I modeled, and you can see here we have the 5 threaded holes like we have on these ones. Some 123 blocks don't have any holes at all, and they're just a kind of block of metal. Some only have a couple holes, like some will have like 6 holes on this front side, and they'll be a different size and stuff. So they're very varied, but this is kind of just the common form that I think most people see and end up using. Here's my completed part with the measurements and the inertia. This was, I believe, I think the material that I used was not hardened steel, but it was a high carbon steel or low carbon steel. I think low carbon steel. Typically, it's just a kind of hardened steel alloy, just because it gives it nice wear characteristics, since you want to have it stay relatively true to its size, so it's not going to get worn down over time too much. And obviously, you can see the length, width, and height, the 1 inch, 2 inch, 3 inch. The distance between the holes, the diameter of the holes, the diameter of the chamfer, and the distance from the edge of the part to the holes and everything. Here we have the part with MDB, so obviously you can just see pretty typical datums and sizing again. Nothing too crazy. And then on the left, in the specification tree, you can also see the sketches and the pad and the multi-hole and the chamfer that I used. Here's the final kind of print. Came out pretty well. Everything's up to spec. Got your general notes, got your principal views, isometric view, and everything. But yeah, came out pretty much as I expected it to. It wasn't super crazy. I did have a little bit of difficulty. Here I kind of was trying to find a good way to demonstrate that there were just the 5 threaded holes, so I kind of tried to specify them with these hole center marks. And then the other kind of big hitch in the project was actually modeling these threaded holes, because in my experience with SolidWorks, you can relatively easily model actual physical threads instead of just like modeled threads where it's just saying this is 3/8 16. But in SolidWorks, it's not too hard to actually have them show up in the model, but in KT it's a lot different, where if you want to model threads, you need to physically model threads, and I was not experienced with CATIA enough yet to really, go in and physically model the threads. So unfortunately here I just had to kind of say that there were threads. And then coming to the conclusion here, I did learn a good amount of just kind of recreating tools from memory. And it definitely has me looking at a lot of other things in my toolbox that I could pretty easily model and maybe even actually work on and make better. I gained a lot of familiarity using CATIA, obviously for the project and over the quarter. And I practiced finding parts and creating prints through multiple workbenches, which is the big, I think in my opinion, hurdle I'm having with CATIA, is just getting used to how many different workbenches there are compared to something like SolidWorks, where it's typically just, SolidWorks, and obviously there's a couple things built into SolidWorks, but you're not really going through that many like tabs compared to something with CATIA where it's like every thing you want to do is essentially a different app. For future work, if I was going to continue on this 1, 2, 3 block project, I would obviously try and model physical threads is the big thing. Create custom bolts to attach the blocks, because some 1, 2, 3 block sets will have some will have like specific bolts that they use that actually end up being flush with the chamfer and stuff. And then I would also do some assembly and attach the blocks together so that you can actually see what they look like as if you were fixturing them or using them for reference or something. And then for my total hours for the class was about 65, and my project hours were about 9.5. Thank you.